Sir, good? Fire.
What?
Good.
Hello, how you guys doing? What's going on? My name is Alyssa Torres. This is Jake Williams. We're here to talk to you guys about ADD, a tool Jake has spent a lot of time on the last several months putting this together. Our presentation is ADD, Complicating Memory Forensics Through Memory Disarray, Memory Confusion. So we're going to talk about the following things. Let's see. Oh, let me introduce myself, and then I'll pass it on to Jake so you can figure out who we are. I'm a forensic investigator, forensic examiner. I've done a lot of incident response investigations, worked for Mandiant for a stint, and I'm also a SANS instructor, author of the memory forensics class at SANS. Ooh, and I have added a bullet to my resume in that I am now the creator of the Snowden Globe. So Jake, when you want to introduce yourself?
Yeah, sure. I guess the quote from Ed probably speaks best for itself. They're a really bad, evil guy. But otherwise, I'm the chief scientist out at CSR Group, SANS instructor, course author. I want to make a plug for CSR Group. Thanks for sponsoring the Fire Talks.
Awesome.
Awesome place to work, too, by the way.
CSR. Very cool. All right, so this is what we got for you guys. This is what we got. I'm going to talk to you. I'm going to talk to you about, well, first I'll give you a sales pitch, but it's only one slide, so you'll notice I'm a little uncomfortable. I told you I'm a SANS instructor, so I just got one sales pitch slide where I'm selling memory forensics to you. How many of you guys are digital forensic examiners, investigators? I see some of, yeah, there's some of my brothers out in the audience. Cool, very cool. Well, I'll tell you why memory forensics is so key to investigations, whether it be employee investigations or malware investigations. But then we're going to talk about how I actually do memory analysis today. Yeah, because I need to set it up, because Jake's going to then tear it down, right? He's going to go through why he can screw around with my methodology. So, of course, there's inherent weaknesses in my methodology. That I'm upfront with my inherent weaknesses, but he's going to then go into his ADD, which is the anti-forensics platform. So he's going to be introducing that to you. So I'll kick it off. So we need memory forensics because, you know, I told you I worked at Mandiant, and we don't pull back full volume images, right, of maybe infected machines. We largely work with what we can triage or what we can get out of memory. So things we can get, I mean, we can even get encryption keys. We can get copies of the registry out of memory. Just really good stuff like network connections. Obviously, this is almost a full system state capture of what's going on in the system. I don't have to sell this to you, right? You're down with the importance of memory forensics. Yeah, so this is my six-step process. When I'm doing memory forensics, maybe working through some of my investigations, this is the six-step process I use. I might start at step 3 because the SOC calls and says, hey, this machine has been beaconing out. So step 3 is like, hey, start with enumerating network connections, finding out who owns the particular network connection that was beaconing out to known bad C2 server. I might start with step 3. But the six-step process is there just in case I need it, you know? If I'm handed a hard drive, or rather a memory image, someone's done for me, and they say find evil, this machine was acting suspiciously, I might start with step 1, which is enumerating processes, right? So step 1, it has a couple components. I'm going to rely on the ability to list. How many of you are familiar with the active process list? The doubly linked list of processes. What? Come on, man.
Like 2 or 3. Oh, okay, there we go.
Yeah, man. All right, all right.
That guy, he took class from me.
Oh, well.
Well, yeah.
I'm not saying anything about that.
Oh.
Yeah.
Wow.
So what I'm saying is, you know, you hit a box and you run like task list, or you run PS list, the sysinternals tool. You're actually walking the doubly linked list of processes, what the system thinks it has running. Because it walks, it starts with this PS active process head, and it walks the doubly linked list of processes. So can this be lied to? Right? Yeah, you're nodding your head. Thank you, thank you. Shout out to you. Of course it can be lied to. That's why we rely on scanning. We scan for process structures based on the pool tag. As you can see up here, man, does this have a pointer?
Oh, yeah, it has a pointer.
Because he's got this crappy version of my same clicker. Let's see if it actually points. Oh, mine's green. All right, I'm pass it on. Pass it on. Thank you, man. Mine's green. Oh, mine's off.
Oh, foiled by the ON/OFF switch.
Yeah. Let's see. What do you prefer, green or red? What? Ow! Yeah. So we got the pool tag. And what does my scanner do? Regardless of what tool you're using, right? I mean, this is how memory forensic analysis tools do the better job of enumerating processes. Because we know processes can be hidden, right? Unlinked from that doubly linked list. So we go through and we enumerate these structures in memory based on pool tags. And I'm showing you one of the pool tags here. So that is the second way of enumerating processes, and that really is step one in my 6-step process of doing the forensic analysis. I'm going to convince them that mine's solid, rock solid, dude. I fear for you.
Just before I tear it down.
I fear for you.
Right, okay.
So I'm on to my second step, because you know what? I enumerated the processes, and I found evil.exe. So the second step in my 6-step process is going through and enumerating objects. Like, tell me what evil.exe, what DLLs are loaded into evil.exe. You would do that too, right? You want to know more about suspicious process. So I would go through that, and knowing what I know about processes, they actually maintain lists of DLLs that they have loaded within their memory space. It's cool. So I actually have 3 lists that I can enumerate. One of them I rely heavily on with my parsing tool. But I can find out what's supposed to be loaded up in there, and I'm walking a list. So we know, yet again, lists can lie, because you've probably heard of something called DLL injection, right? DLL injection. So maybe there's better ways to enumerate process objects. Maybe. I can walk a list of handles too. I'm about to get to scanning. You guys thought I was going to jump into scanning, but I got to walk into the list. There's a list of handles per process. It tells me more about each process. Like, what else in memory does this process actually point to? So I walk a list of handles. These handles point to resources that are in memory, like file objects and stuff like that. Now I'm getting to scanning. All right, so I know if I'm walking a list, it can be subverted. See, I got you covered. I'm walking a list, it can be totally subverted. So I'm going to scan for kernel objects. In this slide, I'm scanning for a file object. So most notable, when a process accesses a file, it will have a handle to said file object. So in this case, dude, I found a file object up in memory when I was doing an investigation that said employee bonus 2013. It's an XLSX. So if I was doing an employee investigation and found this file object, it would point to the fact that user had perhaps looked or loaded this particular file at one point in time while the system had been up and running. Is it notable? It definitely would give me a point in the right direction for the rest of my investigation. I'd probably hit the file system and pull this file off, right? See if it was actually there for me to do further analysis on. In addition, how many of you are savvy and down with the mutant strings? Is there anything notable about mutant strings? Dude, this is baby analysis, right? Before I even was aware of memory structures, Windows memory structures, I was doing keyword scans. They would say, the reverse engineers would be like, Alyssa, grep, strings and grep for this particular mutant string, right? So in this case, they would tell me to look for the poison ivy mutant string to find out whether the machine had this string in the memory image, and if it did, I could make assumptions that it was owned, right, by the malware variant that we were researching. Include it in the scope, right? Include it in my intrusion scope. So another way of enumerating process objects, I think I got Jay covered. The next one, connections. I'm not even going to walk a list of connections because I'm talking about a Vista, maybe a Windows 7 machine. I'm just going to go ahead and scan for said structures in memory. And you can see here I'm scanning for pool tags. So I got 3 different pool tags that I got, UDPA. These are bound sockets. So if a UDP socket is bound or a TCP socket is bound, I want to know about that too. Even that's kind of old school. There might be some crazy nefarious thing that's binding a socket, but then I'm also interested in connections. And if these structures exist, then there was a connection from my local machine to the remote machine that's being represented within this structure. It's good to enumerate, right? I want to find out who the machine is talking to. So I scan for structures and I get the job done. It's glorious. This is awesome. So step 4 in my 6-step process. Detecting injected code. So right here, I'm actually doing, I'm dumping all the memory sections of a particular process. I told you evil.exe, highly suspicious. I want to find out In this case, I'm looking at lsas.exe. Because I think lsas, there's actually a second lsas running on this machine that I'm investigating. I want to find out if there's any injected code, and I do just that by dumping all the memory sections and comparing the portable executables that I find in the memory sections to the ones that are supposed to be there in like DLL list. DLL list tells me how many DLLs were supposed to be loaded up into that process, lsas.exe, and I dump out those memory sections. I actually find more. In this case, 8 were loaded, but there were actually 10 in there when I dumped it out. Again, that's step 4. Damn, step 4 is awesome. Okay, step 5, hooking behaviors. Hooking is not always bad, so you have to keep that in mind, Jake. You have to keep that in mind, because sometimes your antivirus will exhibit these behaviors.
Listen, I just want to say, when I was out in Vegas this year, I learned that hooking is always bad. Just throwing that out there. So.
He points at you. Amen, he says. Amen. Yeah. So here's a couple of structures that I would look at to see if there's any subversion going down in these entries. I got the SSDTs that I'd look at and the IDT. And I'd get the job done because maybe sometimes evil.exe is not going to be something you pick out straight away. You're going to have to get to step 5 in order to find something suspicious about what's going on in a memory image. So, I include looking at rootkit behaviors, looking at hooking behaviors, and that might be your foot in the door to identifying evil, right? So, inherently, there are weaknesses to memory analysis. I know. I'm saying I'm coming forward with this. At least I admit my problems, right? I'm saying when I'm doing a memory capture, I've heard of malware that will evade being captured. It friggin' moves around while my memory acquisition tool is reading physical memory. I've heard of that. You know what I mean? Dude, even Michael Cohen and Johannes Stugin, they wrote an article for Digital Forensics Research Workshop. Am I saying that right? Yeah. Dude, last year, August 2013, they presented some badass research. Look it up. But he says in this white paper that he wrote, memory acquisition tools are running in a hostile environment. Amen, right? I'm saying that's the inherent weakness and the hostile environment.
And I intend to make it that much more hostile.
Come on, man. Give us a break. So there's anti-dumping tools, anti-debugging, things that are running up in memory. Let me give you my last slide. I pay homage to the people who've come before me, right? Jamie Butler, Sherry Sparks wrote the Shadow Walker rootkit, all about desynchronizing the TLBs, man, and feeding my acquisition tool random data. What? Exactly. Subverting acquisition. All right, the second one. I pay homage to the second one. Man. 1 byte abort factor. So these guys presented at Black Hat Europe last year, 2 gentlemen from Japan, and it was all about figuring out what your memory analysis tools need to identify structures in memory and subverting it by 1 byte, therefore 1 byte abort, right? Those memory analysis tools were unable to identify structures in memory. The third one, totally awesome. How many of you heard of dementia? Come on.
This is one that's definitely worth looking up.
Yeah.
Definitely look up dementia.
Dude, there you are. Luka Milkovic presented at CCC last December. I think it was 2012. Yeah, man. Dementia, proof of concept, though he said it was a proof of concept. But it was all about... We hope
it's a proof of concept.
Dude, he would let the acquisition tool fill the buffer with evil, right? But he would go in there before the acquisition, what it had acquired, wrote to disk. That's where he would pull his trash out. He wouldn't let it actually get to the image that was being created by the acquisition tool. So, I mean, that's what I'm acknowledging that's what I'm up against. But I think I got it. I think my 6-step process is infallible. So, all right, man.
Okay.
We're going to hear what Jake has to say. You can use my green.
No, I'm good. That's good. I'm not going to do a lot of pointing anyway. So what is ADD? Well, I like to think of it as a reasonable doubt tool for memory forensics. How many of you guys are familiar with disk-based forensics and looking at timestamps? And how many guys are familiar with timestamp?
They respond to you.
Oh, yeah, there we go. Well, I'm asking easier questions, as it turns out, right? I mean, I'm not down deep in the weeds pretending that everybody already understands memory forensics and stuff. But so how many of you guys are familiar with timestamp? Yeah, right. So all of a sudden, timestamp comes on the scene, what, 10 years ago? It's a long time ago, right? And really, it invalidates, or maybe not invalidates, but certainly throws question when you start looking at timestamps. Now, those of us in here who are real forensic professionals, deep forensic practitioners, you know that you can detect timestamping, right? There are ways to work through and eventually say, okay, I think this was timestamped because everything's not adding up, right? There's some secondary timestamp artifact that we can look at, all the milliseconds or zeros, something like that. The idea with ADD is that we're trying to create, or we have created, the same thing for memory forensics, essentially casting doubt, right? Casting doubt on the memory artifacts that you're finding. So I like to think of it as being able to add fake evidence to be discovered during an investigation. Who here has ever dealt with a SOGD defense? Who in here knows what the SOGD defense is? What is it? Some other guy did it, exactly, right? The some other guy did it defense. This is actually very common. Every case that I work, as it turns out, some other guy did it. I had no idea this guy was so prolific, but he is apparently involved in every case I've ever worked. Okay. So what's the motivation? Well, I want to highlight how fragile our current investigative methodology is. I want to create a proof of concept to show that memory, or did create a proof of concept to show that memory artifacts can be fake. By the way, I love these ball star kicks here, right? These some good counterfeit, the squinty batteries, those are good too. In any case here, essentially doing the same thing for memory forensics, right? Okay, so here's our 6-step process in review, right? So I believe step 1 was to identify rogue processes. So I'll let you answer this, Alyssa. If during the investigation you found the process gfgbls.exe or maybe wincom32, one of our good friends, is the machine infected? If it's an insider case and we're saying the insider had the data, the bonus spreadsheet.xls, are we good? Is the malware on the machine, did that maybe open the file or exfil the file?
I think it would require further investigation.
Require further investigation. Okay,
it depends.
That's fair. I can handle that, right? So okay, good. Identifying rogue processes. Turns out that ADD can actually inject rogue processes into the system. Now, what we're doing here essentially is we're adding process structures, and we'll get into the technical piece as far as how this is done. But one of the things that Alyssa kind of highlighted on here earlier is that we have the ability to scan, and not only can we scan for hidden processes, we can also scan for evidence of the past. One of the dirty little secrets about the way the Windows Memory Manager works is that when it deallocates memory, it doesn't zero it. Right? This is news to a lot of people because if you've ever done any development, when you grab memory, it's supposed to be zeroed. Windows for the last decade plus has zeroed memory, but they zero it when it gets reallocated, not when it's deallocated. So with this scanning technology that Alyssa covered, you can actually scan for artifacts of the past. You can pull up processes that have long ago exited and grab data about those. And in fact, it's a very common forensic technique. Mandiant's Redline does it. Certain scripts within Responder Pro do it. Volatility certainly does it. We regularly, when we're doing investigations, see processes that have not only exited, but in some cases from a previous reboot. Because as it turns out, when you reboot your machine, since roughly the mid-'80s, you don't get that RAM check where it spins through and zeroes your RAM anymore. So as long as power has been maintained on the machine and it was just rebooted, you have those artifacts potentially of other processes in memory. And so what ADD does is just creates those process structures in memory, and you can name the process anything you want. You can give it any parent PID that you want. You can give it any parent PID. I'm trying to think what else relevant in there that was good for... But pretty much the name and the parent PIDs. If you wanted to parent it to services or make it look really, really suspicious, like it was running on the user's desktop, we're good with that too, right? So you would dig deeper then. You need more evidence. Good to go, I've got you covered. So step 2 was to analyze DLLs and handles. It turns out that we don't do anything with DLLs yet. It's just there's only 24 hours in a day. I only had so much time prepping for this and lots of other work to do. ADD does create fake file objects though. So if you were scanning and you found these file objects, would you be concerned?
I would be very concerned.
You would be concerned. Would anybody else in here be concerned if they found these 2 file objects?
He's nodding.
Who's nodding?
The dude over there.
The dude over there is nodding. Why would you be concerned, sir? System 32. Okay, I need a little bit more specific answer than that. We were looking to give away one of the Snowden globes. Who knows specifically why I'm scared of these?
What?
What's that? Nobody in here knows. Oh no, this is very common malware. To the Googles.
Say it.
Ooh, okay, so this is a very specific, I'll save this for another question. This is a very specific variant of malware. Who here follows the Chaos Computer Congress? CCC.
Ow.
Man, ShmooCon's getting lighter and lighter every year. Come on, guys. Okay, so no joke. So the Chaos Computer Congress about 2 years ago, right? Anybody heard of R2-D2? Not the robot from Star Wars, the malware. the German Skype Trojan, right? So this is the German law enforcement Trojan, right? So if I want to do a false flag operation and I happen to know the names of processes that are being used for malware from maybe some other country's Trojan, maybe I go and I insert those in memory, knowing that I'm going to get caught, right? Knowing that I may get caught later, and it points to the Germans. Rock on, right? Who likes the Germans anyway, right? Blitzkrieg and all, right? Okay, good to go. Good to go. I can see this being useful. Maybe. Das gut, yeah, so we could point to file objects. Is that all we can do with file objects, or can we get way more evil? We could. That's actually good for future work. So the question was, could we give it another mutex? I don't implement that yet, but that is no joke on my future work slide. It's like you're reading the future. Is it worth a snow globe? Sure, come get a Snowden globe. Absolutely. No, I'm not going to throw it. Insurance doesn't cover that, right? I'm giving the other one away at the end of the talk, but sure, that's worth a Snowden globe.
May I bestow it?
You created them, by all means. Bestow them, right? Awesome. Congrats, sir. Okay, good. So, woot. Go leak some classified data now. No, wait, no, don't do that. Don't. That's, okay. So is that what you can do with that? Well, maybe we could do some better things. How about some kiddie porn, right? Maybe you're thinking, maybe you're thinking that you want to get some, you want to plant some evidence of some kiddie porn someplace. K-I-T-T-Y, right? Done. Not up here condoning kiddie porn, right? But K-I-T-T-Y porn, right? And so maybe you want to put some artificial evidence there. Maybe you want to put some artificial evidence of any other files, maybe like that bonus spreadsheet .xls, right?
Better.
Yeah, and so it turns out that maybe we can point that to something that's not on the current drive. We might point it to a removable drive, and then send investigators looking for said removable drive with those artifacts of files that never existed because we made them up. Right? I think that'd be cool. Turns out ADD does that, right? So we could also review network artifacts. We can create some fake TCP connections, and those could go to any IP addresses you'd like. Suggestions include flags at the bottom of the slide. Just saying, right? Maybe China, maybe Russia, maybe Iran. I don't know who you want to blame your stuff on today. If you're in India and you want to start a war, maybe Pakistan. I'm not sure, right? But you could basically anybody you like, any port you like, right? Now, all you guys work in awesome places, I'm sure, right? Nothing like the places I have to go to incident response in, right? So I'm sure all of you who use full-take PCAP, right, or full-take net flow monitoring at the perimeter, so you'd be able to detect this type of malfeasance. You'd be able to cross-reference all of it, but it would still take time away. But think if you didn't work in one of those places. Think if you didn't have full-take PCAP, full-take network monitoring at the perimeter, right? You wouldn't be able to go back and correlate necessarily whether these were fake or not, right? So you can blame anybody you want, right, for that network traffic. That's always pretty slick as well, I think. So, evidence of code injection. Look, I don't do anything here yet in this. I failed, right? So, but code injection really relies on scanning objects that are still in memory, right? Alyssa talked about this where she was dumping processes out and looking at the different modules and trying to detect which were injected and which were legitimately in the list. I would love to do that. ADD, though, really is targeting scans of memory that's already been deallocated, right? That's really where we're going with this. I've really racked my head around this because I didn't want to fall down. I wanted to attack all 6 steps, and it turns out that I've only got 5 of the 6. I come to you guys today and begging for mercy and saying that I've only attacked 5 of Alyssa's 6 steps successfully, but I'll take it. 5 for 6 isn't bad. Okay, so checking for signs of a rootkit, ADD has you covered. When we start creating fake processes, those actually show up as hidden processes in most memory forensics platforms today. Right, so, one of the things I forgot about the processes, one of the ways we tell whether a process is from a previous boot, right, either from a previous boot, whether it's exited, or whether it's actually hidden, involves some creation time and deletion time timestamps in something called an eProcess block. Right? Now we know the time the system booted because we can look at the start time for the system process, or smss.exe is another common one where we can find the start time or the boot time of the system. And if we find a process that started after the system booted but has no exit time, it's highly likely that it's a hidden process. If, on the other hand, it actually has an exit time, it means that the process actually stopped. Because Windows goes in and it actually fills in the actual exit time of the process. right? Or we can find processes, again, from previous boots. Regardless, though, these are really going to show up, depending on how we set up ADD, they'll show up as hidden processes. So we can actually fake that we have a rootkit on the box. Why would you want to fake that you have a rootkit on the box? Again, I'm all about slowing down the forensic investigator, right? Making their life pretty miserable. Would this make your life kind of miserable?
Oh, yeah.
Yeah? Okay, good. So we could create some file objects, too, that point to msdirectx.sys or mrxnet.sys. What's mrxnet.sys? Somebody here has to know this one. This one's easier. What's that? Stuxnet. Whoever said Stuxnet was on it. mrsdirectx is, anybody know that one? Oh, that's FU rootkit. So of old Jamie Butler and Greg Hogland fame. Okay, so finally we can dump suspicious processes, right? So we're looking to create dumping failures, right? So basically fake processes and drivers. I haven't implemented the drivers yet, but the fake processes are all there. Unfortunately, they can't be dumped, and this frustrates the investigator, right? Because they like to dump this stuff out and look for evidence of hidden code, code injection, and turns out they can't dump those. This creates a frustrated investigator. It raises the cost to conduct a memory forensics investigation as well. Okay, this is where I dive a little bit further into the tech babble.
You're going to lose them now.
I'm not going to lose people.
Stop responding.
No, it's good. It's good. I think they're going to still respond, but it's good. Okay, so look, this is where I get to say that I love volatility. Right? I absolutely love the guys over at Volatility. Guys at Volatility, please don't sue me. Not that they've ever sued anybody before. I wouldn't know anything about that, but. In any case, please don't do that. I absolutely love Volatility, 100%. I won't speak for Alyssa. So they are the example here, not because I dislike Volatility, right? I want to make very clear, I didn't pick on Volatility because I dislike them. When we wrote the framework, they were the only open source memory forensics platform available. And certainly it's easier to look at and show you guys Python code as far as for the checks that they're making and how fragile these processes are than it would be to pop up a bunch of disassembly on the screen, right, or assembly code on the screen and say, see right there what they're doing? Right, that would have been highly difficult. So again, I show Volatility source code not because I dislike them or because I want them to sue me, only because they were the only open source project at the time. That being said, that's no longer true. There's a new memory forensics platform called Recall, right? So this is a branch of Volatility, or was a fork. Fork is what I was looking for. A fork of Volatility from Michael Cohen and Joachim Metz is working on it. Is that? Joachim. I always mispronounce that guy's name. Joachim Metz. What is he, Swedish? Who knows, right? Whatever. So look, anyway, Recall, I've been in the code. It is way cleaner. If you are looking to, and they actively are accepting user contributions, right? So if you're looking to contribute to a memory forensics platform written in Python, I would highly recommend Recall. Again, the code is cleaner. It has generally the same capabilities, although they use IPython. If you're not familiar with that, phenomenal little set of tools. So anyway, Recall is an alternative. I didn't have time to change the slides out. Again, not picking on the Volatility guys. Again, just trying to prevent bad blood down the road. So process checks, right? This is all rainbows and unicorns, as it turns out. Alyssa talked to you earlier about how we really scan through memory, and we're looking for those PROA tags, or the process tags. Again, pool tags that we're going to locate in memory. It turns out there are a very small number of conditions that actually have to be met. Now, if you think about these pool tags, right, we're talking about a 4-character tag. Think about 4 characters, that's 32 bits. That means there's a 1 in 4.2 billion chance, right? 1 in 4.2 billion chance of finding a false positive. So you have to have some sanity checks so you don't end up with tons of false positives, right? Even though 1 in 4.2 billion isn't bad, we could still have false positives. And so there are a number of checks that you have to satisfy for this stuff to work. One, there's that the tag check, and this actually turns out to be that PROA. I don't know why we spill out on hex, but that's what they did. I didn't want to modify their code without officially branching it and releasing it as open source. And so I went ahead and just copied and pasted it. They also check to make sure that the pool is a particular size. Any process structure is pretty big. In that pool tag header, it actually shows the size. And so they want to make sure this is a particular size. Guess what? Making my pool tag that large, or making my pool that large, is not hard to satisfy. I just say allocate that much memory, right? And then we check to see where it's at. Now, in some cases, it doesn't make sense for it to be free or in the non-paged pool. In this case, an e-process structure can show up in the paged pool, the non-paged pool, or it may have been allocated and then later freed, right? And so We also have a case where it's actually checking the pool index. I'm not going to dive deep into the structure here because then I'm truly going to have people glaze over. But they also have a little function we'll look at in a second called check process that they implement, because this can't be all the sanity checks we do. That would be insane, right? We would have all kinds of fake processes popping out without any maliciousness, right? So they maybe work a little bit for this. Right, so there's a whole second set of process checks. Now this is a case where I've actually added some print statements in here just so you can see what's actually going on. Right, I didn't want to. Yeah, again, I'm not modifying and unreleasing GPL code. Want to be very clear to the volatility developers. If they would like a copy of this fine code, they can contact me at their leisure, and I'll gladly hand it back over. So the not that I'm afraid of being sued or anything. So the E process, there's an E process, the offset 0, there's a process control block, and this is something called a K process. Bottom line, it points to this thing called a DTB, or a directory table base. How many people in here are familiar with directory table bases? Got like no geeks in here. Okay, how many of you guys have heard about paging before? Rock on, awesome. Okay, the directory table base points to the set of page tables in memory. All right, how cool is that? So basically what happens here now is that they can make the mappings between physical and logical memory. Hey, guess what? If you've got any process structure that doesn't point to a set of page tables, right? If it's 0, the pointer number is 0, no wins, right? There's no way that could be a legitimate process. So they check to make sure the directory table base isn't 0. I'm not going to explain why it has to be modulo hex 20, but basically there's a bunch of flags that go in there. Just take for granted that should be modulo hex 20 should not equal 0. And then the next thing they do is any real process has to point to, right? Any real process is actually going to point to a number of threads, right? So threads actually are the units of execution. The fact that Windows separates processes and threads at the scheduler level is what gives Windows rootkits an easy way to hide processes. It's very difficult on Linux, right? On Linux, the scheduler actually would like to schedule processes. Who knew, right? On Windows is like, process, that's just a little naming structure. I'll go schedule threads. So the E process actually points to a bunch of threads, again, a bunch of scheduling structures. And basically what we're looking at here, it's a doubly linked list, like Alyssa showed you earlier with processes. Each process has one for threads. And volatility goes through and checks to see, basically, is the forward link and the backward link, do they basically both point into kernel space, right? And what they're looking for there for the kernel space is anything in the high 2 gigs of RAM for an x86 machine, right? So in layman's terms, exactly that, right? They were pointing into kernel space for the list heads, and the directory table base isn't 0, and that funny little calculation works out. So those are all the conditions, right? If we look at this is a very tiny number of conditions to have to satisfy. How easy do you think this is to fool? Yep, really, really easy, right? It turns out all you have to do is go ask a device driver to create that particular pool tag for you, populate it with something that looks like an e-process structure, and all of a sudden your memory forensics platforms say, hey, look at this other process over here, right? The kittyporndistributor.exe, for instance, or Malcolm, or whatever we want to call it. So we have a number of TCP connection checks as well. It turns out this is way, way, way easier to fool. There are far less checks, even though that looks really, really complicated, right? There are far less checks that we actually have to work out, right? So in layman's terms, really what we're looking for is the local address structure has to be populated. You satisfy that one condition, you're done, right? Fill in the local address. Of course, that's not going to help you much. You want a remote address, and you want it to point to Russia, China, Iran, somewhere not in the United States, right? Wait, maybe you want it to point in the United States. I don't know. Depends. So in any case, right, basically the second set of checks will kick in if you haven't populated that, but it points to the process structures. Again, this stuff is rockin' easy to do. The file objects. This one's phenomenal. It is so stupid easy to fake file objects. I'd be amazed if other people haven't been doing this before, right? I'd be absolutely amazed if nobody's done this before. This is the total set of checks. Basically, it says, hey, make sure that the tag looks like this, and that, yep, basically the size is bigger than hex 98, right? And there's nothing else to see there at all. I was absolutely blown away when I found out that there were no other checks being made here. And then I thought about, what checks would I really make? And if there were more checks, would I just break those too? Yeah, probably, right? So, but again, there aren't any more checks being made there. So those are the 3 that we really broke out and started looking at pretty hard. So what's next, right? What's next for ADD? The first order of business is absolutely to clean up the code. My code is horrible, right? I'm going to release it here in the next couple of days, but I'm going to be the first to tell you it is absolutely horrible. It only works on Windows 7 Service Pack 1, the x86 version, because I needed a target operating system to start attacking first, and that seemed like a good way to go. What else do I want to do? As the gentleman in the back that got the stone globe pointed out, I would love to be able to insert mutexes. Those actually don't get any, well, they have one check, but it's very, very trivial to bypass. Symlinks are another check, another category we'd like to be able to fake. Drivers, DLLs. Bottom line is use your imagination, right? Your imagination really is the end of this as far as what you can do, what kind of evidence you can plant, and basically how bad can you make the memory forensic investigator's life, right? As far as countermeasures, right? So, as I was pitching this to a couple of people, one person in particular, being my boss, said, "Hey, I would prefer it if you didn't release something unless you have a solution to the problem." And I was like, "Cool, yeah, that's good. I think that's a responsible disclosure kind of guy, right?" I tend not to be a responsible disclosure kind of guy, and Doug reins me back in. So create better sanity checks. I think that's the thing we could start doing. I think they should definitely create better sanity checks, but that's a cat and mouse game, right? You create a better sanity check, I'm going to reverse engineer it, and just like the forensic tool authors, they only coded as hard as they had to prevent false positives, right? Now I'm creating false positives, I'll have to code a little bit harder, and I'll code a little bit harder. And I feel like at the end of the day, this is a cat and mouse game that I get to win. And I don't say that lightly. I think at the end of the day, it's going to be really difficult to code checks in that we can't fake. What other countermeasures do we have? Well, I hate to say it, but this is really a case you're going to have to learn to actually do memory forensics, right? And that's tough, right? I know it's tough. As opposed to just running a tool and analyzing the output and saying, good to go, right?
No one does that.
Yeah, we do that. But, okay, so, but again, this is the difference between PBF. Anybody here familiar with PBF?
PBF, come on.
Somebody in it. Push button forensics, right? So good old push button forensics. NCase, FTK, X-Ways, where you click the Forensicator Pro button and it cranks out and says, here's the evidence, right? So this is the difference between push button forensics and learning how to read an MFT, right? The master file table yourself. Realistically, the artifacts that I'm creating, while they're good enough to pass muster for these tools, they're really not, if you know what you're looking at. I think you can probably determine which ones are forged and which ones aren't. Definitely right now you can. Certainly in the future that's going to get harder. But as far as countermeasures, again, certainly knowing how to do this yourself is going to go a long way. And then one of the things that you could do is just hunt the ADD driver in memory. In order to work out pool tag allocations, I had to load a device driver. Right, so that means that on the machine that you're attacking for memory forensics, you're going to have driver loading permissions. So your average user, the one that Alyssa was doing the investigation on, may not have permissions to load a device driver without some privilege escalation exploit or something along those lines. Even if they do have the ability to load a driver, you could just hunt that down in memory, right? Right now it's not hard to find, it's add.sys. Yeah, that's kind of a fail, right? But as it turns out, I'll just randomize the name and or the code inside the driver if somebody starts pattern matching code. So again, this is another cat and mouse game that at the end of the day, I think, correct me if I'm wrong, but I think I win this one at the end of the day.
What do you guys think?
Randomizing? No? Maybe?
See, he's
yeah?
pointing to me. He's pointing to me.
Who?
You're pointing to me, right?
Oh, fail.
Like,
okay.
I will never agree to that.
Yeah.
He's shaking his head no.
Okay. This is the other question that I had asked when I pitched this is, won't the bad guys use this? Yeah, I think so, probably, right? Secretly, I hope they do, right? Because at the end of the day, right, I want to raise the bar, right? I've heard too many people, memory forensics, when I got into this working with H.B. Gary, yeah, I know, H.B. Gary, right? When I got into working this with H.B. Gary a number of years ago, this was a real fledgling field. Not a lot of people had done any memory forensics at all. It was like, you want to do what? On what? Right? I mean, it was 2007 or 2008, Andreas Schuster won a bunch of stuff with DFRWS with, was it 08 maybe? So we're not talking about a long time ago, in 2008 till now, right, that we've really been doing mainstream memory forensics. And so we had Harlan Carvey, Andreas Schuster, a number of guys with DFRWS writing Perl scripts, right, to go crank through memory and do basically grep searches is what it boiled down to.
Brendan
right?
Dolan Gavitt.
What's that?
Brendan Dolan Gavitt.
Brendan Dolan Gavitt? Yeah, I'm so sorry. I want to make sure and credit everybody. And Alyssa's my creditor machine there, right? She cranks them out, right? But the reality is, I mean, again, this is a really young field. When we got into it, almost nobody was doing it. now I hear people at the conferences we go teach and in discussions are like, I found it in memory, therefore it happened. I've heard people preaching memory is ground truth. If you found it in memory, they definitely had it open, right? Thinking, how do you know? How do you know they had it open? They're like, because I saw it in memory. Oh, okay, right? Not anymore. And if you hear anybody say that, because I saw it in memory, right? Say ADD. And just finish the conversation, right? Because at this point now, and if they say, I found it in memory, but I reverse engineered the structure and I could see where Jake didn't fill out this appropriate field correctly, then rock on, right? But otherwise, I want to really shut that down. And I'd like to make forensicators work just a little bit harder, because at the end of the day, I really am a bad guy. So what makes you think they aren't doing it already? Yeah, I don't know. I haven't checked. Right? I haven't, when the memory analysis that I've done, I haven't checked. I've done just good enough, rock on. I've done just good enough forensics. I'm being given the 10-minute sign, but that's okay. I don't have 10 minutes left. So, but the bottom line is, have you checked? And then do you even know how? And this isn't an insult to anybody, right? This stuff is hard, right? A lot of this work takes place at the end of the day, right before the tools get written, the red line, the HP Gear responder, the volatility, the recall. Before this stuff gets written, there's a lot of time spent in Winbag, right? Everybody's favorite debugger, right? With such an awesome user interface, Microsoft, right? Such an awesome user interface, so we spend a ton of time in Winbag. Most forensics professionals do not know how to do Winbag, right? Most forensics professionals do not know how to read the MFT. They press the find evidence button, right? And again, what we're looking to do here is raise the bar. I want to push the limits of tools and techniques. I think that's good for everybody, and I suspect that there will be better detection tools coming soon, brought to you by somebody. I'm 100% confident that somebody will step up and respond to this. So that's all I've got. Any questions or comments? Or I'll be releasing the code the next couple of days. If you watch the Twitter feed, I'll post the link to it. It is really raw at this point. I'd hoped to have it released, but I was working an awesome social engineering campaign and had way too many users give me passwords. So.
Oh, here? Okay.
Question?
Yeah. So is the simple poor man's fix to turn on the memory check again in BIOS to let that run just to clean memory when you reboot your machine every morning or every night?
Ooh, I like that, right? So one of the questions we just had was, oh, he said it over the microphone. I don't even need to repeat it. Awesome. I'm so used to having to repeat the question. So yes and no, right? Yes and no. If it's a question of basically, are you trying to... If you're an insider threat, yes. But if... what I'm thinking about here at the end of the day is, if I was trying to plant evidence for the last reboot, yes, that's a win, right? So if I try and plant something like to show a process that was available on the last, or was running on the last reboot, you would know that was fake because you had that flag set. If it's a case of I'm trying to plant file objects for kiddie porn, no, not really, right? Because we don't have timestamps on those objects, unfortunately, for you to look at, and so you wouldn't be able to differentiate whether those are from this boot or the last boot. So good question. You actually made me think about it for a minute. But at the end of the day, no, it's not going to protect you. Sir.
Can you fully simulate like a malware campaign on your machine with ADD, like all the aspect of, let's say, Stuxnet? They just targeted you. You can say, oh, it was them, not me.
Yeah, that's an excellent question. So the reality is today, no. We can create the pointers. So Stuxnet, for instance, you would be looking at mrxnet.sys, mrxcls.sys. What is it, kernel32.aslr with some random numbers behind it. So I can create the file objects for those. I could create a couple of fake LSAS processes and deallocate the memory. But as far as any mutexes, today I can't fully create the campaign. That being said, I think I can put enough in memory that it'll cast reasonable doubt. And ultimately the question then becomes, you found X, why didn't you find Y and Z, right? Yeah. And so I feel like for the average investigator, while I can't completely replicate a campaign right now, yet, right? I think yet is the answer. I think we're moving towards that.
So are there any other static strings that you might find in memory as a result of having ADD?
Yeah, so the question is there any static strings that we find in memory? And really the only one would be the file object that we communicate through. And again, we can randomize that name. So that's a device driver file object.
Have you ever considered maybe using the process hollowing technique halfway as a cheat not to have to use kernel implant?
Yeah, so the question, well, have we thought about using using a process hollowing technique? The problem there, we actually did look at this. Originally, I don't like to do driver development, by the way, because as I referenced earlier, I don't think the WinBag interface is awesome. And so if I can get away with, well, I'm lazy too. I like to do things easy. So originally, we looked at not doing driver development, just faking the pool headers. It turns out that the Windows Memory Manager likes to reclaim user space memory very, very quickly. And kernel space memory, on the other hand, I can just leave allocated without having to leave a process running. So I like this because I can load the driver, I can create my fake artifacts, and then I can unload the driver. All right? And I like that. The process hollowing technique, as soon as I closed it, I found that Windows would reclaim that memory very, very quickly. If I allocated the memory and then deallocated it and then asked basically to create new artifacts, it would re-give me the memory. It would re-gift me the memory, and I'm not down with that. I wanted to create lots of fake artifacts. He's bringing the mic. Sorry.
Dude, I need to get Homeboy in the back, man.
Okay, gotcha.
I'm pointing to you.
When you're unload your driver, doesn't Windows keep that memory? Does it zero the memory out when you free your driver?
Excellent question. So the gentleman asked, when you unlink your driver and you unload it, does Windows zero out the memory? Not only does it not zero out the memory, that's a good question. Not only does it not zero out the memory from my driver, it actually puts it in a recently unloaded modules list. It's a debugging structure. So again, I can name that anything I want, something like hal.sys or, and again, it comes down to a code patterning search. Without a doubt, sir, you're definitely coming up with a good way to detect the driver itself, but not necessarily the fake artifacts it's created.
Even if you name it hal.sys, I mean, the forensic analysis might find a file handle, a straight file handle, but unallocated, then there's going to be a different path to real hal.sys, and that itself is going to be a red flag.
Potentially, yeah, without... Yep.
Okay.
No, definitely. So it's all about finding, in that case, you're attacking the driver itself and not necessarily the artifacts that have been left behind by it. Our whole goal here, by the way, too, is not necessarily to remain undetected, the driver itself to remain undetected, but the whole goal of ADD, just to make very clear, was basically to pollute physical memory images with fake evidence so that forensic analysts would have a hard time figuring out what was real and what was fake. Yes, certainly. I can't argue that.
Same question about how is it possible to make it invisible that the ADD wouldn't be traceable?
Is it possible to make it invisible? I feel like yes. I mean, can I back up?
Yeah.
Yeah, I feel like that I can randomize the name of the driver and the code. There's good what do I want to go with here? There's good precedent for doing this. WinPmem, which is a open source memory dumping utility, actually
wait. Who is that written by for the globe? WinPmem. What? Who?
No, not Michael Halelight. So who wrote WinPmem?
Who wrote WinPmem for the second globe?
Scudet?
Yeah,
I'll take
man.
that. Go for it.
Michael Cohen.
Yep, Michael Cohen, by the way, as the Scudet. So, okay, so basically WinPmem, though, there's a good precedent for this. It's a memory dumping driver, and basically to fight that whole hostile environment piece, right? Again, it randomizes the name, and actually has some code segments that are randomized. So, makes it very difficult for an anti-dumping tool to locate it in memory. I suspect that we could do the same thing with I haven't examined again how deeply we could try to make using rootkit technologies, right, to try to make this undetectable in memory, but I feel like it's pretty doable. Any other questions, sir? So the question is, yeah, do malware authors only have to load add.sys to instilled out? Yes, absolutely. And again, I think whether you find the driver there loaded, previously loaded, unloaded, again, the goal here is to raise the bar, right? I know I'm going to get flamed. Yeah, I got 1 minute now. I know I'm going to get flamed for this, right? For putting anti-forensic stuff out on the market. That being said, I think it's already happening. It would surprise me if it's not. It was so trivially easy to do. So, but good question, sir. Excellent. So the question is, can we do statistical analysis of adjacent processes in a memory dump to figure out if it was injected or faked? And unfortunately, the answer is no, because of the way that the difference between physical memory, the semantic gap between physical memory and virtual memory spaces. I don't have time to get into it here, but if you look at the way memory gets laid out, we're actually attacking the way the scans work against a physical memory dump, and again, some of this memory has been deallocated from the virtual memory dump. One more question. So the question is, have we considered tampering with data? That sounds crazy like a rootkit, right? Sounds crazy like a rootkit. It actually sounds crazy like it might be a cyber weapon, which might be something that was prohibited for sale or released under the NDAA this year. But yes, we definitely considered it. So as you may be able to tell by my answer. So. Yeah, that's a great point though. So the question, the question really comes down to, would we be interested actually in faking, right, or in basically reparenting a process or changing the name of a running process or the path of it? Sure, yeah, absolutely. What bad guy wouldn't be interested in that, right? So yeah, and it's 100% possible to do. Again, it just sounds a lot like a rootkit and was kind of scary to release here. So, okay, I think I'm done on time. So thanks.
Solid, dude. I fear for you.
Just before I tear it down.
I fear for you.
Right, okay.
So I'm on to my second step, because you know what? I enumerated the processes and I found evil.exe. So the second step in my 6-step process is going through and enumerating objects. Like, tell me what evil.exe, what DLLs are loaded into evil.exe. You would do that too, right? You want to know more about suspicious process. So I would go through that, and knowing what I know about processes, they actually maintain lists of DLLs that they have loaded within their memory space. It's cool. So I actually have 3 lists that I can enumerate. One of them I rely heavily on with my parsing tool. But I can find out what's supposed to be loaded up in there, and I'm walking a list. So we know, yet again, lists can lie, because you've probably heard of something called DLL injection, right? DLL injection. So maybe there's better ways to enumerate process objects. Maybe. I can walk a list of handles too. I'm about to get to scanning. You guys thought I was going to jump into scanning, but I got to walk into the list. There's a list of handles per process. It tells me more about each process. Like, what else in memory does this process actually point to? So I walk a list of handles. These handles point to resources that are in memory, like file objects and stuff like that. Now I'm getting to scanning. All right, so you're actually walking the doubly linked list of processes, what the system thinks it has running. Because it starts with this PS active process head, and it walks the doubly linked list of processes. So can this be lied to? Right? Yeah, you're nodding your head. Thank you, shout out to you. Of course it can be lied to. That's why we rely on scanning. We scan for process structures based on the pool tag. As you can see up here, man, does this have a pointer?
Oh yeah, it has a pointer.
Because he's got this crappy version of my same clicker. Let's see if it actually points. Oh, mine's green. All right, I'm pass it on. Pass it on. Thank you, man. Mine's green. Oh, mine's off.
Oh, foiled by the ONOFF switch.
Yeah. Oh, let's see. What do you prefer, green or red? What? Ow! Yeah. So we got the pool tag. And what does my scanner do? Regardless of what tool you're using, right? I mean, this is how memory forensic analysis tools do the better job of enumerating processes. Because we know processes can be hidden, right? Unlinked from that doubly linked list. So we go through and we enumerate these structures in memory based on pool tags. And I'm showing you one of the pool tags here. So that is the second way of enumerating processes, and that really is step 1 in my 6-step process of doing the forensic analysis. I'm going to convince them that mine's solid. I'm going to talk to you. I'm going to talk to you about, well, first I'll give you a sales pitch, but it's only 1 slide. So you'll notice I'm a little uncomfortable. I told you I'm a SANS instructor, so I just got 1 sales pitch slide where I'm selling memory forensics to you. How many of you guys are digital forensic examiners, investigators? I see there's some of my brothers out in the audience. Cool, very cool. Well, I'll tell you why memory forensics is so key to investigations, whether it be employee investigations or malware investigations. But then we're going to talk about how I actually do memory analysis today. Yeah, because I need to set it up, because Jake's going to then tear it down, right? He's going to go through why he can screw around with my methodology. So, of course, there's inherent weaknesses in my methodology. That I'm upfront with my inherent weaknesses, but he's going to then go into his ADD, which is the anti-forensics platform. So he's going to be introducing that to you. So I'll kick it off. So we need memory forensics because, you know, I told you I worked at Mandiant, and we don't pull back full volume images, right, of maybe infected machines. We largely work with what we can triage or what we can get out of memory. So things we can get, I mean, we can even get encryption keys. We can get copies of the registry out of memory.
Sir, good? Fire.
What?
Good.
Hello, how you guys doing? What's going on? My name is Alyssa Torres. This is Jake Williams. We're here to talk to you guys about ADD, a tool Jake has spent a lot of time on the last several months, putting this together. Our presentation is ADD, Complicating Memory Forensics through Memory Disarray, Memory Confusion. So we're going to talk about the following things. Let's see. Oh, let me introduce myself, and then I'll pass it on to Jake so you can figure out who we are. I'm a forensic investigator, forensic examiner. I've done a lot of incident response investigations, worked for Mandiant for a stint, and I'm also a SANS instructor, author of the memory forensics class at SANS. Ooh, and I have added a bullet to my resume in that I am now the creator of the Snowden Globe. So Jake, when you want to introduce yourself?
Yeah, sure. I guess the quote from Ed probably speaks best for itself. They're a really bad, evil guy. But otherwise, I'm the chief scientist out at CSR Group, SANS instructor, course author. I want to make a plug for CSR Group. Thanks for sponsoring the Fire Talks.
Awesome.
Awesome place to work, too, by the way.
CSR. Very cool. All right, so this is what we got for you guys. This is what we got. Just really good stuff like network connections. Obviously, this is almost a full system state capture of what's going on in the system. I don't have to sell this to you, right? You're down with the importance of memory forensics. Yeah, so this is my six-step process. When I'm doing memory forensics, maybe working through some of my investigations, this is the six-step process I use. I might start at step 3 because the SOC calls and says, hey, this machine has been beaconing out. So step 3 is like, hey, start with enumerating network connections, finding out who owns the particular network connection that was beaconing out to known bad C2 server. I might start with step 3. But the 6-step process is there just in case I need it, you know? If I'm handed a hard drive, or rather a memory image, someone's done for me, and they say find evil, this machine was acting suspiciously, I might start with step 1, which is enumerating processes, right? So step 1, it has a couple components. I'm going to rely on the ability to list. How many of you are familiar with the active process list? The doubly linked list of processes. What? Come on, man.
Like 2 or 3. Oh, okay, there we go.
Yeah, man. All right, all right.
That guy, he took class from me.
Oh, well.
Well, yeah.
I'm not saying anything about that.
Oh.
Yeah.
Wow.
So what I'm saying is, you know, you hit a box and you run like task list, or you run PS list, the sysinternals tool.